on optimal multi-tier resource allocation of cloud LAN in 5G using machine learning. Abstract. The networks are evolving drastically since last few years in order to meet user requirements. For example, the 5G is offering most of the available spectrum under one umbrella. In this week, we will address the resource allocation problem in 5G networks. To be exact, in the cloud radio access network CLAN, the radio access network LAN mechanism involve multiple network topologies that are isolated based on the spectrum band, and it should be enhanced with numerous access technology in the deployment of 5G network. CLAN is one of the optimal techniques to combine all the available spectral band. However, existing CLAN mechanisms lacks the intelligence perspective on choosing the spectral band. Thus, CLAN mechanism requires an advanced tool to identify network topology to allocate the network resources for substantial traffic volumes. Therefore, there is a need to propose a framework that handles spectral resources based on user requirement and network behavior. In this work, we introduce a new CLAN architecture modified as multi-tier HCLAN in a 5G environment. This architecture handles spectral resources efficiently. Based on the simulation analysis, the proposed multi-tier HCLAN architecture with improved CU in network management perspective enables argument granularity, end-to-end optimization, and guarantees the quality of service by 50% over the existing system. Radio access network, quality of service, basic unit, quality of experience. 1. Introduction. In the midst of this data revolution era, the evolution in the network generation should be steered largely to hold up faster data-oriented services that can be fulfilled in 5G. The forthcoming network is planned to evolve based on the user expectations and demand, which is turned from the basement for the 5G network goals. Some of the predominant targets of 5G are low latency, high bandwidth utilization, and interoperability. To achieve the significant goals of 5G, efficient network management and compatible network architecture is required. The 5G network incorporates various emerging technologies like software-defined network (SDN), network function virtualization (NFV), and modern edge computing (MEC), which are proposed by the main working group of 5G networks like NGM and 3GPP. The 5G consortium has planned to utilize the available spectrum of all the communication and data sharing band of the licensed spectrum, such as LTE, UMTS, and unlicensed spectrum like Wi-Fi. The advanced antennas with multiple input and multiple output MIMO technologies can be adopted in the evolving 5G to provide higher data rate 3 and 4. The closer requirement of the future 5G networks cannot be accomplished by the existing radio access network LAN, wherein the baseband unit (BBU) and radio unit (RU) are considered. Meanwhile, the cloud-enabled services in 5G ecosystem cater heterogeneous communication framework, utilizing advanced virtualization techniques. The network virtualization stimulates multi-service and multi-tenancy for efficient network operation and service provisions, which in turn offer new fragrant, service-oriented, and edge-cloud 5G architectures with enhanced quality of experience. Thus, the current LAN architectures need to be further extended with various virtualization techniques to develop cloud LAN. CLAN is ultimately the correlation of access point APs to the pool of BBU via a turbo transport links in the control unit CEO, which conquers the limitations in the traditional LAN. However, CLAN requires an intelligence techniques to recognize the topology of the network in the mobility stage and to locate the resources. As the vast traffic volume created by the sample radio signals are directly transported to the CEO, the next generation networks are expected to run consistently based on varied user behavior and the spectral stability that depends on both the user's environment and network behavior. Thereby, seamless service can be ensured for the needy edge core requirement by predicting the most advantageous network that can render service. The Trojan optimal network will offer seamless service with highly sophisticated running and decision-making through machine learning techniques. Machine learning is the most robust artificial intelligence domain which compromises of assured techniques for improving the operation and management of networks and engineering applications in the future cellular networks. The machine learning algorithms employed for mobile networks can endeavor plentiful opportunities to solve advanced threats and enhance connectivity. Hence, the machine learning aid CLAN architectures are expected to perform as an intelligent radio propagation medium which can automatically assess the available spectrum and can regulate the power to be transmitted in the interest of energy conservation. It is believed that innovative CLAN with machine learning techniques form a new design prototype in the 5G networks architecture, which will most probably introduce considerable modifications in the air interface and the tensile network management. The CLAN invites a fruitful solution that solve the issue of the interoperability by utilizing various spectrum bands by running the dynamic changes in the network paradigm. In this article, we propose a multi-tier HCLAN in 5G by adopting the machine learning techniques to address the current limitations of huge traffic in the BBU pool of existing architecture. The proposed architecture is also improved to facilitate augmented granularity, end-to-end optimization, and guaranteed quality of service. This article organized as Section 2 discussed the literature on the recent research solution that contributes to the domain of 5G and machine learning. The feasibility in the physical deployment of LAN in heterogeneous network is explained in Section 3. In Section 4, proposed multi-tier HCLAN architecture with the running tier is preferred. The performance of the proposed system is analyzed in Section 5 under various assumptions and 5 scenarios. Finally, Section 6 concludes the article with the interference of analysis made on the proposed system. Related was the 5G wireless networks is evolving to satisfy the end-user requirements such as seamless connectivity, even with high mobility, low latency, and interoperable connectivity. The Mobile Communication Working Group and Consortium focus on providing new spectrum band, on improving spectral efficiency and throughput when considering the business models related to coverage area and reliable broadband access. To meet the user requirement, LAN is redesigned to scale the parameters such as throughput, many devices and connections. Concerning user plane, UP, and control plane, the evolving 5G LAN architecture supports mechanisms that relate traffic to fulfill quality of service and control D2D connectivity. LAN technology also assists in reducing traffic service and enable network slicing. However, there is a possibility for LAN to be designed up with heterogeneous networks like Wi-Fi and LTE small cells, i.e. HANET. By the recent advancement in the cloud computing paradigm, the integration of cloud technology with LAN named CLAN is believed to be a productive solution to solve the heterogeneous interoperable problems. CLAN is the most promising design for mobile network system to provide scalable and smooth traffic transmission. CLAN integrated with HANET has achieved a flexible and configurable dense deployment of small cells. Sharing holds the potential in giving effective communication and information exchange among the terminals. When sharing is modeled with the assistance of SDN, it gives us space to configure and manage the dense small cells deployment. And to enhance the QoS, sharing BBU pool is relocated into BBU and remote radio head RH. BBU is enabled with the central processing unit to provide network coordination and management. BBU helps in reducing the traffic when deploying the small cells. Headnets, which contain thousands of small cells. In BBU, there is a possibility of several other challenges, like effective radio resource management spectrum and energy efficient networks to enable QoE resource management in small cells and multi-hop networks. By considering operator radio resource management, modified sharing frameworks has been proposed to provide an improved engagement of resource allocation. It also enables flexible resource management with improved QoS parameters such as throughput and fairness. The modified sharing frameworks allow flexible resource management, i.e. the amount of resource used for the end users is made dynamic. Several issues came into existence when sharing is combined with Headnet, such as coordination, multi-point, transmission, and receptions, resource management in self-organized networks, and improved spectrum utilization with energy estimation in cellular systems. In sharing, the transmission demand between BBU and RRH are considered for the differentiation of service and RRH demand in the transmission links, i.e. backhaul is improved by balancing the workload which is labeled as multi-point transmission. In sharing, BBU and radio access unit RAU are isolated to provide centralized processing and reduce operational expenses, while mapping RRH and RAU in heterogeneous networks. The hardness of configuration and energy efficiency are the prime parameters to be considered. Sharing along with the orthogonal frequency division multiplexing access OFDMA techniques help to map BBU and RAU for providing the configurable backhaul transmission and effective energy utilization. Efficient pre-coding scheme has been designed for the environment like sharing with full channel matrix using beamforming, i.e. zero forcing to reduce energy consumption and computational complexity in corporate transmission. Centralizing processing of thousands of small cells helps to perform multiple cell joint scheduling, but interference, problem, and frequency reuse play a significant role in the dense scenarios. Next-generation networks are often planned for the improved data rate, which is used for many essential applications like sensing, resource management, etc. Challenges faced by radio technology helps to provide creative learning and decision-making platform for efficient frequency planning based on radio frequency spectrum. A heterogeneous network meets spectral inefficiency, interference, transmission, and power efficiency concerning QoS and Headnet face the problem of efficient radio resource management and optimization for user satisfaction. To overcome the various network paradigm problems, artificial intelligence techniques such as machine learning, fuzzy neural networks, etc. play an important role to provide practical solutions. When artificial intelligence is deployed on the CRM by integrating Headnet-based stations, use dedicated backhaul to provide guaranteed backhaul, and the small cells deployment offers seamless connectivity to offload the data in traffic. If sharing is automated or made intelligent, then RRH's backhaul connection of LAN can be combined with the BBU pool to create a centralized processing unit. Due to the tremendous traffic generated by mobile users, the future mobile network deployment is going to be extremely complex. The spectrum utilization is densely operated networks is a challenging task, and if machine learning is used as an optimization tool to optimize the resource allocation scheme will be enabled to downlink HCLAN. HCLAN aims the reduction of interference problem to maximize the energy efficiency and to guarantee the QoS between RRH and all viewing present in the network. In this paper, we propose a multi-tier HCLAN architecture that can provide seamless connectivity by monitoring the network's conditions and the user behavior based on the behavior pattern to available required technology in the future. Also, the proposed multi-tier HCLAN considers the problem of interference to get optimized resource allocation further to improve the QoS.